So let's move on to the next question, guys. In this question, we know that k is a positive integer, right? And we also know that the value of k is greater than or equal to 13 factorial plus 2 and less than or equal to 13 factorial plus 13. And we have to tell which of the following options must be false. The keyword here is must, right? So k is prime, composite, even, odd, perfect square. We have to tell this. Okay. Since we know that the value of k is greater than or equal to this and less than and equal to this, so we can say that k is equals to 13 factorial plus 2, right? Because k value is greater than or equal to. So we can say that k is equals to 13 factorial plus 2, right? Now tell me one thing, what is 13 factorial? 13 factorial is 13 into 12 into 11 into 10 up to 1, right? So we can write this as 13 into 12 into 11 into 10 up to into 1, right? And plus 2, plus 2. So tell me one thing, can I take 2 common from the entire thing? I can take 2 from common from here, right? And I can take 2 common from here, for example, right? Because this will definitely be an even number because, for example, this is 12, this is 10. So there are a lot of 2's in this, right? So I can take 2 common from this entire thing, right? So I take 2 common from this entire thing, right? Or if you don't want to think about it that ways, you can also think about it in this way, that for example, you can take 2 common from this part. Can you take 2 common from this part? Yes, definitely we can, because for example, I can write 13 into, I can write 12 as 2 into 6, right? Into 11 into 10 into 1. So I can take 2 common from here. So I will get some number k, right? I will get 13 into 6 into this. So I'm writing it as k, right? So 2 into k, and this is plus 2. I hope you are understanding this. So what did I do? I firstly broke 13 factorial and I wrote it in this form, right? Now I am taking 2 common from this. So I took 2 common from this and this is some number k. I don't know. I have to calculate. But I don't care about that. And this is plus 2. I hope this should be fine, right? So now I can write this as 2 times of k plus 1. I hope this should be clear. So what does this mean? This means that this number 13 factorial plus 2 gets converted into this. This number has been converted to this, right? So this means that this number is a multiple of 2 because this is, for example, you can write this as 2 times of, for example, p, right? Where p is equals to k plus 1. Where p is equals to k plus 1, you can write 2p. So basically 2p is equals to this, right? So that means this number is a multiple of 2. I hope this is clear. Because this number can be expressed as 2p, that means this number is a multiple of 2. So I hope this should be very clear, right? Is this clear to you, right? So that means if this number is a multiple of 2, then can it be prime? No, right? Because prime numbers are numbers which have only 1 and themselves and the number itself as the factors. But we know that this is a multiple of 2, right? So that means it cannot be a prime number. So we had to tell which of the following must be false. So the answer is prime, right? This is one case. For example, now let me talk about another case. Because in order to tick must, we have to satisfy all of them, right? Now let's suppose I take k is equals to 13 factorial plus 3, right? So the first number is 13 factorial plus 2, 13 factorial plus 3 plus 4 plus 5 plus 6 up till plus 13. So this is the next number in sequence, right? Now tell me one thing, this can be written as 13 into 12 into 11 up to into 1 plus 3, right? Now I can break 13 into, I can break this into 3 into 4. I can break the 12 into 3 into 4 into 11 up till into 1 plus 3, right? Now what I do, I again take 3 common from here. So if I take 3 common, I will get 13 into 4 into this something. So let's suppose it's some number k again, and this is plus 3. So now this becomes 3 times of k plus 1, right? This becomes 3 times of k plus 1, which means that this number, is a multiple of k, right? So which means it's a multiple of 3. 3 times of k plus 1, this means that this number is a multiple of 3. Similarly, we can show it's a multiple of 4, multiple of 5, multiple of 6, multiple of 7, up till multiple of 13, which means that any of these numbers is not a prime number, and that is why which of the following must be false? This is false because k is not prime. I hope this is clear. I mean, you can assume this as k or p, whatever, any constant, right? So this is not prime because it's a multiple of 3. Similarly, when we take 13 factorial plus 4, it will come out to be multiple of 4. So that is also not prime. Similarly, when we take 13 factorial plus 5, that will be a multiple of 5. So it is not prime. Similarly, when we come up till 13 factorial plus 13, it will be a multiple of 13. So that is also not prime. So any of these numbers is not prime. And that is why which of the following must be false? That this number is prime, this is false. So I hope that is clear.